Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
Chandrasekhar, the genius who predicted black holes. Imagine being a young astrophysicist, full of new ideas, and proposing a theory like this: if a star gets too massive, it'll collapse instead of continuing to burn.
Sounds like science fiction, right?
But this was the real-life experience of Subrahmanyan Chandrasekhar, a story that's even more dramatic than most movies.
Here's how it went down.
At just 20 years old, Chandrasekhar challenged the fundamental assumptions about stars. He hypothesized that if a star's mass exceeded a certain limit, it couldn't keep burning and expanding as we thought. Instead, it would collapse.
Now, this idea might seem a bit far-fetched at first, right? Stars are supposed to burn forever, aren't they?
But what followed was even more surprising. His theory ran headfirst into the wall of established authority, none other than Sir Arthur Eddington, a giant in the field of astronomy at the time. Eddington was a big deal, basically the Pope of astrophysics, and he didn't hesitate for a second.
He dismissed Chandrasekhar's idea as impossible and preposterous. Imagine being just a young scholar, facing that kind of blow from someone at the top of your field. Must have felt like trying to stand up to a giant with a stone. But here's the kicker: 50 years later, Eddington's rejection was proven completely wrong. What was once seen as a laughable theory turned out to be a cornerstone of modern astrophysics. Today, when scientists talk about black holes or the Chandrasekhar limit, they're essentially proving him right. The young man who was ridiculed has now become a key figure in our understanding of the universe. Funny how that works, right? Those who were quick to dismiss him are now part of the past, while his legacy continues to shape the science we know today. A lesson in never backing down, even when the odds seem impossible. After all, as the saying goes, fortune favors the bold. In 1910, the city of Lahore in India seemed quiet and unassuming, but if you knew that Subrahmanyan Chandrasekhar was born there, you'd realize this seemingly ordinary place was a goldmine of scientific history. Picture this: he had a father who was a civil servant with an exceptional grasp of mathematics, and a mother who was a cultural educator. Their home was always filled with the buzz of knowledge. This was his intellectual birthright.
Now, you might be thinking, with genius running through his veins, he must have been destined for greatness from the start. But here's where it gets interesting. Chandrasekhar didn't come from just any family. His family produced not one, but two Nobel laureates.
That's right, two. One of them was his uncle, C.V.
Raman, who won the Nobel Prize in Physics in 1930 for his discovery of the scattering of light. So, imagine this family where scientific discussions were a regular part of dinner conversation, and no one ever talked about real estate prices, just quantum mechanics.
But don't be fooled by the family's illustrious reputation. Chandrasekhar wasn't exactly the shiny star being groomed for greatness from birth.
Unlike the stereotypical genius in movies who's forced to memorize poetry and solve math problems from an early age, he had a natural gift for mathematics, and by the time he was 10, he was reading college-level textbooks.
Yes, you heard that right, 10 years old, flipping through university math books. To most kids, these books might as well have been written in another language, but for him, it was just another challenge. However, this gift didn't make his path any easier. You might think a genius would have a smooth ride to the top, but you'd be wrong. Despite his incredible math skills, his journey wasn't all smooth sailing. The expectations placed on him, especially with a Nobel-winning uncle, created immense pressure. Everyone around him, from his family to the community, believed he was destined for greatness. It was like standing in the shadow of a giant, constantly aware of the weight of that legacy. Maybe it was this very pressure that made him more than just a natural talent. What set Chandrasekhar apart wasn't just his ability with numbers, but his resilience in the face of high expectations. He learned how to stand tall despite the shadows of his family's accomplishments, carving out his own path. It wasn't an easy journey, but those challenges ultimately shaped the man who would change the way we understand the universe. As they say, pressure makes diamonds. And in this case, it certainly did. He was a mystery from the start. Can you imagine what most 19-year-olds are doing? Probably enjoying their first taste of university life, right? Not for Chandrasekhar. At just 19, fresh out of the Presidency College in India, he was already writing his first scientific paper. And it wasn't just about simple math formulas, oh no. This paper tackled deep, complex questions in astronomy and physics. While most people his age were just beginning their college journey, Chandrasekhar was already diving into complicated formulas about stars, light, and gravity. Talk about a genius accelerator. He wasn't just ahead of his peers, he was light years ahead. But you think that's where his story ends? Think again. The moment that truly changed his fate didn't happen in a classroom, it happened on a ship. Picture this, it's 1930, and a young genius, fresh out of college in India, is boarding a ship bound for England. You might imagine him carrying a stack of textbooks, ready to continue his studies. But this wasn't your typical student journey. On that ship, there were no fancy computers, no lab equipment, not even a proper desk. The only resources he had were the ocean waves and a piece of scrap paper. Yes, you heard that right. The ship rocked, the sea swayed, and most passengers were struggling with seasickness. But while others were focused on keeping their balance, Chandrasekhar was doing something extraordinary. Day after day, in the cramped quarters of the ship's cabin, he spent hours doing one thing, calculating. This wasn't just a trip, it was a dialogue between him, mathematics, and the universe. Combining quantum mechanics with relativity, he arrived at some mind-blowing conclusions, like the idea that a star's mass is limited. In simple terms, if a star gets too heavy, it will collapse and turn into a black hole. Can you picture it? A young man, filled with the weight of knowledge, scribbling equations in the midst of an endless ocean. While others struggled to keep their balance, he was laying the groundwork for some of the most significant scientific discoveries of the future. But as his excitement grew, so did the realization that these new theories might anger some of the biggest names in astronomy. And sure enough, one of the most powerful figures in the field, Sir Arthur Eddington, wasn't going to accept a young man coming out of nowhere with such revolutionary ideas. His own theories had been untouchable for years, and Chandrasekhar's conclusions were about to set him up for a massive clash with the scientific establishment. That moment on the ship wasn't just a breakthrough in science, it marked the beginning of a scientist's journey to hold on to his beliefs in the face of the world's doubts. And from there, the legendary story of Subrahmanyan Chandrasekhar was just getting started. As the saying goes, smooth seas never made a skilled sailor. And in this case, the stormy ocean would shape him into one of the greatest minds of modern science. When Chandrasekhar arrived at Cambridge, his world became a lot more complicated. Now, getting into Cambridge in 1930 wasn't a walk in the park, especially for a young man from India. Born in 1910, he finally got his shot in 1930, and it wasn't just about academic challenges, it was about navigating a whole new level of. You may be right, but I don't agree. Cambridge wasn't just about breakthroughs, it was about learning how to handle the pushback from those who didn't like your breakthroughs. In the early 1930s, Cambridge was one of the leading institutions in physics, and it was home to a towering figure, Arthur Eddington. He was like a rock star in the scientific world. His every word could stir up global discussions. Eddington was one of the most respected scientists of the time, particularly known for his work in general relativity and astronomy. He was the king of the academic realm, and Chandrasekhar, the young Indian, was just starting to make his mark in this fiercely competitive field. In 1935, at a key conference, Chandrasekhar took the stage. He nervously yet carefully explained his theory about the mass limit of stars and the formation of black holes. He described how stars, once they became too massive, would collapse into a point of no return, creating black holes. His words were measured, yet full of conviction. He knew this theory could change the future of astronomy. But what happened next shattered his confidence. Sitting in the audience was Eddington, and after listening to Chandrasekhar's presentation, his face betrayed no surprise or admiration, only the classic expression of an authority figure who disagreed. He stood up, squinting his eyes, and slowly said, "How could nature possibly allow such an absurd thing to happen?" The room went silent. In that moment, Chandrasekhar probably felt his heart sink. His theory was no longer just a bold idea,
it had been flatly rejected by one of the most influential physicists in the world. To put it in modern terms, it was like presenting a brilliant dish you'd made, only for the top chef to stand up, knock it off the table, and tell you, this dish could never taste good.
Talk about a crushing moment.
And then, the academic world began to take sides.
You can imagine the scene at Cambridge. Scholars split into two factions.
One group sided with Eddington, dismissing Chandrasekhar's ideas as wild fantasies, while the other, including Chandrasekhar himself, believed these were groundbreaking concepts.
But, in the end, most backed Eddington. After all, who would dare challenge a scientific titan like him?
Chandrasekhar found himself not only facing this academic setback but also being marginalized due to his youth and his foreign background.
Imagine being a young scholar, just starting out in your field, only to be hit with such fierce opposition.
The sense of isolation must have been overwhelming, a feeling only those who've experienced it firsthand could truly understand.
But as the saying goes, when the going gets tough, the tough get going.
And Chandrasekhar's journey was just beginning.
Facing the rejection from Eddington and the academic elite, Chandrasekhar's world felt like a mountain collapsing in on itself.
His theory, about the mass limit of stars, was completely dismissed and became the subject of ridicule. For years, the mainstream scientific voices isolated him, labeling him as just another ignorant young man daring to challenge the boundaries of science. With all this pressure mounting, Chandrasekhar began to realize that his future might no longer lie in England. The academic world that once promised him opportunity had now cast him aside. So, he made a tough decision: he would leave the UK, leave the world of rejection behind, and seek out a new beginning.
When the whole academic world doesn't believe in you, you have to switch continents. That's how he must have felt.
So, with countless unanswered questions and theories dismissed, he set sail for the new world, America. Specifically, Chicago, where he would get the chance to prove himself all over again.
And that's where everything changed.
In America, at the University of Chicago, his destiny took a complete turn. Here, he found not only academic freedom but also a fresh start in his personal life. In 1936, he married Lalitha, a sharp, rational woman who would stand by his side through many scientific challenges. Their marriage, like his new career, became a source of strength and motivation.
Love and career, rebooted together.
For Chandrasekhar, both his professional and personal life were starting anew at the same time. At the University of Chicago, he began teaching, passing on his love for science to the next generation. What he didn't expect was that this new chapter would bring him to another peak. In his classroom, Chandrasekhar mentored future Nobel laureates Yan Qining and Sundar Lee.
Can you imagine? 2 Nobel Prize winners in one class.
For most professors, this would be a dream come true, but for Chandrasekhar, it was just another day at the office. He took pride in seeing his students achieve greatness, and what was even more incredible was that their success was directly linked to his early work. It was as if destiny gave him a warm hug, saying, "You were right, your early perseverance wasn't in vain."
2 Nobel Prize winners in one class.
If you were Chandrasekhar, witnessing this moment, you'd probably think, what an honor. Not just for himself, but for all the struggles and solitude he'd endured. He had not only revived his career but found new meaning in his life. America became his second chance to shine, a place where he was no longer isolated and where new triumphs awaited. During this period, you could call Chandrasekhar's work ethic the ultimate scholar, or even a scientific machine. He was almost like a never-stop working force, switching fields every 10 years to dive into something completely new.
Sounds superhuman, right?
But it's true. Every decade, his mind would leap over new thresholds, jumping into a different scientific domain. From stellar physics in his early career to black holes, then delving into quantum mechanics and fluid dynamics, his academic journey was a constant cycle of self-challenge.
What's even crazier?
Every time he shifted focus, he'd write a classic book.
Yes, you heard that right, classic. Most scientists might write one groundbreaking book in their lifetime, but Chandrasekhar was writing a new one every 10 years. It's like he had some secret time management superpower.
While others were still working on their masterpiece, he had already completed a whole library of influential works. Imagine his bookshelf: The Structure of Stars, Fluid Mechanics, Physics of Black Holes and Stars, each one became a must-read in academia.
But wait, there's more.
Not only was he a productivity powerhouse, but he was also a brutal editor. Yes, he worked on several academic journals and kept an ironclad standard for every submission.
Want to submit a paper to him? Get ready for a second exam. That's right, his review process was incredibly tough. If your work didn't meet his high bar, you had to revise and resubmit until he was happy. Submitting to him was like facing a challenge. Submitting to Chandrasekhar was like taking a second exam. You could write 10 pages, and he'd cut it down to 5, completely reframe your direction, and make it better. Imagine how many people, after seeing his strict review standards, probably gave up on their papers.
Don't get me wrong, it wasn't about being picky, it was about pursuing nothing less than academic perfection. He demanded the same from his own work and from his colleagues.
Nothing short of flawless was acceptable.
Every detail mattered, even the derivation of a single equation had to be checked over and over, ensuring there wasn't a single flaw. This relentless, perfection-driven approach to work was like an academic superhero show.
While everyone else was trying to balance their busy lives, Chandrasekhar seemed to always transcend ordinary limits, hopping from field to field, reaching new peaks of scientific understanding.
Every time he switched focus, he'd produce another iconic book.
His editing?
It was as if academic research itself had become a form of art. This was Chandrasekhar's way: never stop, never compromise, always chasing the highest peaks of academic excellence. And in the end, his years of relentless effort paid off. In 1983, Chandrasekhar finally stood at the peak of the scientific world. The Nobel Prize in Physics was awarded to him. At over 70 years old, with his hair turned white, his academic achievements still shone brightly across the scientific community. And this time, when his name was mentioned in the Nobel announcement, it wasn't followed by doubt or criticism. Instead, it was a deep affirmation of his groundbreaking theories. Let's rewind to the 1950s, when his theories faced so many setbacks, especially that cruel dismissal from Arthur Eddington, calling his ideas absurd. Back then, the scientific community largely sided with Eddington, and Chandrasekhar became the subject of ridicule. But fast forward to 1983, and all those doubts were crushed by history. What was once mocked became the foundation for Chandrasekhar's ultimate recognition.
The Nobel Prize didn't just honor him.
It also acknowledged William A. Fowler, another scientific giant, highlighting their joint contributions to astrophysics. It might sound like a team effort, but think about it: the young man who had been isolated and dismissed was now, 50 years later, receiving the Nobel Prize. All his persistence and hard work had laid the very foundation for this award.
The reversal was powerful, can you imagine? That absurd theory turned out to be the key to their Nobel-winning work.
Chandrasekhar's theory about the mass limit of stars became central to black hole theory, the core reason he was awarded the Nobel Prize. That "I told you so" from years ago had become the strongest comeback in the history of science. If you could see Chandrasekhar's expression in that moment, you'd understand how much weight was behind those emotions.
This was perhaps the longest "I told you so" in scientific history.
His confidence and persistence had transformed into an absolute victory for his theory. This wasn't just personal glory, it was the ultimate rebuttal to those who had ridiculed and rejected him. 50 years later, science had made its grand reversal, and the young man once seen as an outsider was finally standing on the world stage, accepting the applause he so richly deserved. It's a classic case of what goes around, comes around, and in his case, it came with a Nobel Prize. In his later years, Chandrasekhar remained that same curious scholar, endlessly fascinated by the universe. As time passed, his research shifted from stellar physics to the mysterious world of black holes. By the 1960s and 1970s, black hole theory became the focal point of his work. Despite already being a giant in astrophysics, earning academic recognition was no longer his concern. For him, the allure of science wasn't about awards or titles, it was about diving deeper into the cosmos. Chandrasekhar delved into the formation and properties of black holes, particularly through his Chandrasekhar limit, which revealed the maximum mass a star can have before it collapses into a black hole. While black holes had long been viewed as mysterious monsters of physics, he saw them not just as theoretical oddities, but as real, deeply philosophical celestial bodies. By this point, black holes were no longer just abstract theories, they became the philosophical mirror of his later research. But his later years weren't just about obsessing over equations. Chandrasekhar's thinking had transcended beyond math and physics to explore more philosophical domains. He became interested in aesthetics, particularly the beauty of science. He once said, "The precision of science and the harmony in aesthetics are one and the same, both have an inner drive to pursue truth." He believed there was no sharp divide between scientific discovery and artistic creation. In fact, they often resonated with each other. He saw the elegance behind scientific laws, much like the beauty found in art. During this period, his life became richer in many ways. He continued teaching at the University of Chicago, and despite his age, he never missed an opportunity to engage with students. His lectures weren't just full of physics wisdom, they often ventured into philosophical discussions, especially the blend of science and art, rationality and emotion. In the mid-1970s, he began to explore a unique idea, the aesthetics of science. He engaged with artists and philosophers, discussing the relationship between physics and art. These conversations weren't just academic, they were personal explorations of what beauty meant in science. Unlike many modern scientists, he didn't see science as just a collection of cold equations. To him, science was a language that expressed the harmony and beauty of the universe. In 1980, he published Science and Beauty, the Aesthetic Philosophy of Physics, where he explored the aesthetic aspects of physics, especially how beauty could be distilled from the simplest mathematical equations. He said, "Just as a painting uses colors to express its beauty, science uses equations and formulas to show the structure and harmony of the universe." This wasn't a traditional physics book, it was a philosophical work, pondering the crossroads of science and aesthetics. Even though Chandrasekhar had firmly established himself academically, he remained humble and low-key. Unlike many famous scientists, he didn't seek out the public spotlight. Instead, he focused on his research and writing. He didn't involve himself much in politics or public events, dedicating most of his time to teaching and passing on his thoughts about science and philosophy to the next generation. As the saying goes, actions speak louder than words, and for him, that meant sharing knowledge in the classroom, not in the media. Chandrasekhar's life wasn't just a career, it was a continuous journey of discovery, combining the logic of physics with the beauty of the universe. And in the end, it wasn't the Nobel Prize or public recognition that defined him, but his relentless quest for understanding and the elegance that science could reveal. Chandrasekhar's name is forever tied to one groundbreaking theory, the Chandrasekhar limit. This discovery in the early 1930s revolutionized our understanding of stellar life cycles. To put it simply, this limit defines the maximum mass of a white dwarf as staggering 1.4 times the mass of our Sun. Exceed this limit, and the white dwarf can no longer hold its own. It collapses, transforming into something far more mysterious. Think of it like the weight limit of a star. Just like how we all have a healthy weight range, stars too have a cutoff point. Go past it, and it's time for a drastic transformation or collapse. But this seemingly simple limit rests on some truly complex physics. A white dwarf is the final stage of a star's life when it can no longer fuse elements in its core. It shrinks to a tiny but incredibly dense body. But once a white dwarf's mass exceeds that 1.4 times the Sun's mass, the force keeping it from collapsing, the electron degeneracy pressure, can no longer hold. It implodes, becoming a neutron star, or in the most extreme cases, a black hole. This theory, which Chandrasekhar proposed when he was just 20 years old, cemented his place in the heart of astrophysics. Stars have a weight limit, sounds almost too simple, doesn't it? Yet, just like how we hit a weight limit and risk our health, stars face a similar fate. When they exceed that mass threshold, they cannot remain in their original form and must undergo a cosmic transformation. And that transformation is the death of a star, turning into black holes, supernovae, and other celestial marvels we now know so well. The response to the Chandrasekhar limit was mixed at first. Many dismissed it as meaningless theory, just abstract mathematics. But over time, this theory became one of the cornerstones of cosmology. It gave us a crucial framework for understanding how stars die, and without it, black holes might have remained an unsolved mystery. Now,
let's talk about stellar death and the birth of black holes. When a star reaches a certain mass, its life cycle ends. The death of a star usually involves a massive explosion, a supernova. In this explosion, the star releases all its remaining energy, becoming brighter than entire galaxies for a brief moment. But not every supernova turns into a black hole. Only the most massive stars, after undergoing a supernova explosion, can collapse into black holes. Through these explosions, we witness some of the most intense and dramatic phenomena in the universe, the birth of black holes. All of this ties directly back to Chandrasekhar's early work. Without his discovery, we might never have understood stellar life cycles so clearly. The first black holes we observed were born from the collapse of massive stars after supernovae. In that sense, black holes represent the ultimate death of a star. Now, let's talk about another concept linked to galaxy evolution: dynamical friction. This process occurs when stars in a galaxy interact gravitationally, transferring energy and causing their orbits to spiral inwards. This phenomenon doesn't just affect stars, it can alter the very structure of a galaxy. In the core of a galaxy, stars fall inward due to dynamical friction, eventually leading to the formation of supermassive black holes. This insight gives us a deeper understanding of how galaxies evolve and how they can develop the intricate structures we see today. At the same time, Chandrasekhar's contributions to magnetohydrodynamics, MHD, and plasma physics are just as important. He didn't just focus on stellar death and black holes, but also studied the behaviors of interstellar gas, solar winds, and cosmic magnetic fields. By researching MHD and plasma physics, Chandrasekhar helped us grasp the movement of matter in space and the processes behind nuclear fusion critical to understanding how stars generate energy. In nuclear fusion, he realized that the behavior of interstellar gas and plasma is tightly tied to magnetic fields. Understanding these fluid dynamics helps us unlock the secrets of fusion, the very process that powers stars. Without this knowledge, we'd be left in the dark about stellar energy sources, the flow of interstellar matter, and even the evolution of our own solar system. Finally, Chandrasekhar's work on black hole mathematics remains one of his far-reaching contributions. For him, black holes weren't just physical phenomena, they were a mathematical challenge. His work laid the foundation for future physicists to understand the formation of black holes through complex mathematical models. The gravitational fields, spacetime curvature, and the movement of matter near black holes all became describable through intricate equations, which continue to guide astrophysics experiments today. Chandrasekhar's work didn't just expand our knowledge of the universe, it gave us the mathematical tools to understand the very forces that shape it. Through his theories, we've gained a clearer picture of the cosmos and the incredible phenomena that drive it. His legacy is not just in the stars he studied, but in the tools and insights that continue to shape the way we explore the universe. He wasn't flashy. He never sought the spotlight. Throughout his life, Chandrasekhar quietly pursued the mysteries of the universe. His name was once ignored, even dismissed by some of the top figures in the academic world. Yet, he never rushed to defend himself, nor did he react with anger. Instead, he chose silence. He chose to wait for the right moment, for the universe to eventually speak for him. Waited 50 years might sound like a punchline. A young man making calculations on a ship, only for the world to accept those findings as truth decades later. In those years, Chandrasekhar faced endless doubt, isolation, and setbacks. But he never rushed to prove himself. He always believed that time would provide the answer. And in the end, time did more than just answer, it crowned him at the peak of scientific achievement. Eventually, the universe spoke for him. This phrase might be the perfect summary of his life. No fanfare, no applause, just the quiet growth of his theory in the cosmos, eventually earning its rightful recognition. Just as he predicted in his youth, black holes are the final fate of stars, and his theory, the seed of black holes he planted as a young man, grew stronger with every passing year. Today, when we look at the first ever photograph of a black hole, we're witnessing the proof of a young man's calculations made on a ship. Back then, he was alone, armed only with a piece of paper and an unwavering dedication to science, calculating a truth far ahead of its time. Decades later, scientists used the most advanced technology to capture the image of that black hole, where the curved light and warped spacetime are the very reality of what Chandrasekhar theorized. The calculations he made on that ship didn't just change science, they made the universe speak for him.
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.